Hey, hi everyone. So today we'll discuss about one of the most famous system design problem, that is TinyURL. So we'll not only discuss about the system design of TinyURL, but also how to implement it using Azure. So we'll have a live demonstration of the service, the how to implement it and how to use it. So without wasting more time, let's get started. So before I start, let me give you my quick introduction. My name is Piyush and I do have 10 plus years of experience in software industry, currently working as a senior software engineer in Microsoft. Okay, so let me discuss about the agenda for today's discussion. So I'll start with the introduction of TinyURL, a brief of TinyURL, why do we use it, and then we'll also discuss on the foundational blocks of TinyURL, right? We'll see that there are some blocks which will be receiving a long URL, and then finally a tiny URL will be generated. And those blocks will eventually use some kind of algorithm like MD5, hexadecimal numbers, and base64. So we'll also discuss on those key concepts as well, because those key concepts will be used eventually to build a tiny URL service, right? Once we have enough uh, understanding on these key concepts, we'll finally build a block level diagram. And once we have that block level diagram, we'll eventually replace those blocks with the actual services we'll be using in Azure to build this tiny URL service. So once we replace those blocks with the actual services, the complete high level architecture will be created, right? Once we are done with the high level architecture discussion, finally we'll implement the tiny URL service on Azure. That will be a live demonstration of the service. Thank you. What is TinyURL? So TinyURL is a shortened web address that redirects to a longer original URL. And where do we use it? So what happens is uh, on some of the platforms, uh, there is a character limit, right, to share a text. In that case, if you want to share a time, in that case, if you want to share a URL which is lengthy and crossing the character limit allowed on that particular platform, you cannot share the lengthy and long URL. So in that case, we create the tiny URL and share it across to the users. So that's how, and that's where we use the tiny URL. The question is, how do we generate it? So there are multiple online services available where we can generate the tiny URL from the actual URL. Okay, let's understand this with the help of example. So at the left side, we can see there is a user trying to access this long URL. When the user sends a request, it actually lands to the Azure portal, right? And when we replace this actual URL with the tiny URL, the user makes a request on this tiny URL, which eventually redirects to the actual URL, and user gets the same Azure portal. At the top, we have TinyURL, which redirects us to the URL for which this tiny URL has been created. And eventually, when we access this tiny URL, we lands to the actual web page on the browser. So now the question is, how is it implemented at the backend? So now look at it from the programming point of view. When a user sends a request to create a tiny URL, a post call is triggered to the backend. So when the request comes to the backend, API management layer receives that request. This is the first layer of our service. You can think of when we create the RESTful services in Java and we use Spring frameworks, we create controllers, right? You can think of the request is coming to the controller layer. Once the request is received by API management layer, it passes on that payload to the short URL service. Once that request is received by short URL service, it generates the tiny URL and save it to the persistent URL DB. So let's look what's inside the persistent URL DB. If you see at the right side, we see 7 character long magical string which is mapped to the actual URL, which actually generates the tiny URL which is sent back to the user. And using those 7 magical character along with the tiny URL, whenever user make a request, it actually gets redirected to the actual URL. That's how it look like at the bird view. At top we see the tiny URL, and then we have a mapped URL to that tiny URL, and then user access the actual website mapped to that tiny URL. So this is the foundation of our block level architecture. First request comes to the API management layer. It passes on to the Short URL service does some kind of processing, creates 7-character long magical string, which is mapped to the actual original URL and save it to the persistent URL DB. So let's deep dive into short URL service. So this short URL service contains key management service, which takes original large URL and generates the 7 magical characters. So let's deep dive inside this key management service. As we know that this key management service reads the large URL and generates the 7 magical characters. This complete operation is a bit complex. So that's why the complete operation is divided into 3 modules. This key management service consists of 3 modules. First module read that large URL and generate some output. That output of first module is the input for second module, and it does some processing and then generates some other output. The final module read that output generated by the second module and then further does some more processing and generate the final 7 magical characters. So let's discuss the module inside key management service. So the first module is Hashomatic, which reads the original large URL. It reads it and generate the equivalent MD5 string. So as we have already discussed, the output of one module will be the input of another module. The another module is base64 magic, which reads that particular generated MD5 string, reads it, and then generate the equivalent base64 string. Once the string, once the base64 string is generated, there is another module called TinyKeyPicker. So this TinyKeyPicker does nothing but reads that particular base64 string and takes first 7 characters of that base64 string. So if we look closely in the key management service, we discussed the key management service consists of 3 modules: the Hashomatic, base64 magic, and TinyKeyPicker. Let's discuss what are they doing one by one, or summarize what we have discussed so far. So Hashomatic does the conversion of the input string to MD5. Let's assume the long URL is a kind of a string, right? And Hashomatic reads that particular string and converts it to the MD5. Now the next base64 converts that MD5 to base64 string, and then TinyKeyPicker choose the 7 characters from that base64 encoded string. We discussed about key management service and the 3 different modules which reads the large URL and converts and uh, and then create 7 magical characters. When I was working on to create the video on the TinyURL, I thought of not to limit this video to discuss only the system design for TinyURL. I thought of to deep dive. I thought of to discuss and deep dive more into the construct of the key concepts we are using to create TinyURL, like what is MD5, what is base64, and we can also choose 6 characters, 7 characters, or 5 characters from the base64 encoded string as well. So we'll go and deep dive onto these key concepts as well, so that we understand the logic behind using the MD5 base64 and why are we choosing 7 characters, why not 5 characters or 6 characters. So let's deep dive into Hashomatic. As we have already discussed, Hashomatic takes original large URL and converts it into MD5 string. Let's deep dive into what is MD5. So MD5 is a 128-bit value which is represented by 32 hexadecimal numbers, where each hexadecimal number is represented by 4 bits. So I think to understand MD5 more clearly, we should also deep dive into what is hexadecimal number and what is the logic behind these hexadecimal numbers. The hexadecimal numbers are the representation of base 16 number system, where number starts from 0 till 16. All the numbers from 0 till 9 are represented through actual numbers, and the numbers beyond 9, that is 10, 11, 12 till 15, are represented by the alphabets A, B, C till F. The reason behind representing numbers with the alphabets, the numbers beyond 9 till 15, is because, for example, if we take 11 and 11 is represented by B. The reason behind representing 11 by B is because if you take 11, we see 1 and 1, and 1 is also a hexadecimal number, and someone can consider that there are two hexadecimal number. To avoid that confusion, 11 is represented by B, and till 15 is represented by F. So that is the reason we use alphabets to represent numbers: 10 by A, 11 by B, till 15 by F. Let's take a reference from this table. If we look at this table, we see the hexadecimal number representation of the decimal numbers. The confusion is clear here. If you see 11, which is represented by B, and if we can also consider that 11 by individual 1 and 1, which is also a hexadecimal number. To avoid that confusion, the numbers beyond 9, 10, 11, 12 till 15 are represented by A, B, C, and F. Every hexadecimal number here is represented via 4 bits of binary. 0 is represented by 0000, and F at the last is represented by 4 ones. So let's understand it with the help of one example. So 15 is a decimal number. The binary representation of 15 is 1111. And if we map this 4 bits 1111 with the hexadecimal table, we see 1111 is represented by F. Now, how do we convert decimal to hexadecimal number? The answer is simple. First, we take decimal number and then convert that decimal number into binary. Let's take one example, that is 10, which is written in our hexadecimal example table. The binary representation of 10 is 1010. If we take those 4 binary bits and compare it in the hexadecimal table which we discussed earlier, the equivalent hexadecimal number of 1010 is A. Likewise, if we take another example of 255, let's convert that in a binary. The binary representation of 255 is 1111 1111. Once the number is converted into binary, we divide that binary number in 4 bits of batch, and we take each batch and map that batch in the hexadecimal number. So if we see 255, if we take 255, we see 8 binary numbers, and we divide that 8 binary number in 2 batches. First one is represented by 4 ones, and another one is also represented by 4 ones. Let's take first 4 ones, and then if we map those 4 ones in hexadecimal table, we see 1111 is represented by F. Likewise, another 11 is represented by F. So the equivalent hexadecimal of 255 would become F and F. Now let's understand what is the benefits of using hexadecimal number. So hexadecimal numbers are more compact than binary numbers. So 4 binary numbers are represented through hexadecimal. That's why it is more compact than binary. As well as it is easier to read and write hexa than binary for large numbers. There are multiple other benefits of using hexadecimal numbers. I think we have enough understanding of hexadecimal numbers now. Let's move back to MD5 now. So I think we have enough understanding of what is hexadecimal numbers. So MD5 algorithm provides you a fixed 128-bit value of 32 hexadecimal numbers of whatever string you provide. So it's a kind of compressor which compresses large string into 128-bit value or 32 hexadecimal characters. So now let's move on to our next service. Before I move on to next service, let me recap what we have discussed. We discussed about Hashomatic service, which takes the original large URL and convert that large URL into equivalent MD5 string of fixed length. Once it is converted, once the string is converted into equivalent MD5 string, Now base64 magic module comes into the picture. As we have already discussed, the output of hashomatic would be the input of base64 magic module. What base64 magic module does is it takes that MD5 string and convert that MD5 string to base64 string. So the MD5 string is consumed by base64 magic, and once it is consumed, base64 magic module will convert that MD5 into equivalent base64 string. Let's understand how. So now let's discuss about the base64 magic module, how we are converting MD5 to base64 string. So let's make a pair of each MD5 character. Why are we making pair is that it is easier to understand, because one character of MD5 represent 4 bits, and if we take a pair it will represent 8 bits, which is 1 byte. It is easier to understand, and we can also avoid taking pair as well, and we can follow the steps we'll discuss going forward. Once we take the pair, then convert each pair in the equivalent binary numbers. once the binary numbers Once the MD5 characters are converted into binary numbers, let's take the binary for two first pairs and make a batch of 6 bytes and convert those 6 bytes into equivalent decimal numbers. Now we have to follow the same steps which we followed in hexadecimal number. I mean, mapping decimal numbers to equivalent hexadecimal character. So likewise, we have to do the same steps to convert MD5 in base 64 characters. So this is the table for base 64 to convert decimal to base 64 characters. We got two numbers, 25 and 58. 25 is mapped to base 64 character, that is Z, and the decimal number 58 is mapped to base 64 character, which is 6. So this is how the conversion would look like. We have divided bits in 6 bits of batches, then converted that 6 bits of batches to equivalent decimal number, and then we'll map the decimal number to equivalent base 64. So that's what we have to do for complete binary string. Make a batch of 6 bits and then convert each batch to equivalent decimal numbers, and then map that decimal number to base 64 character, and that's how the complete MD5 will be converted into base 64 string. So let's look at the MD5 conversion to base 64 in a single go, step by step. So first we created a pair of MD5 received string, which is completely optional. It is just for readability. Once the pairing was done, we converted each pair to equivalent binary, and once the conversion from MD5 to binary was done, we created a batch of 6 bits of received binary. Once the batching was done, we converted that batch of 6 bits to equivalent decimal number, and once the decimal conversion was done, we mapped that decimal to base 64 character, and that's how we received MD5 to equivalent base 64 string. Let's look at what we have discussed so far. So we discussed about the hashomatic service which received the long URL, the string, and converted that string to MD5. Once the MD5 conversion was done, base64 took that MD5 string and then converted that MD5 string to equivalent base 64 string. Now let's move on and discuss about another service, that is TinyKeyPicker, which will now take that base 64 string and pick up the 7 characters from it. All right. So now let's discuss about another service, that is Tiny Key Picker, which takes the base64 string as an input and picks up 7 characters out of it, right? So for example, the Tiny Key Picker is consuming base64 and then it's picking up 7 characters out of it, which will create a tiny URL. So let's move ahead and look at everything we discussed at a glance, right? So first we generated MD5 from the incoming large URL, and then we converted that MD5 string to the binary equivalent, and then we took, or we created 6 bits of batches, and then we converted that binary to base 64. Uh, so we already have created 6 bits of batches. We converted that 6 bits into the decimal, and then we map that decimal to equivalent base 64 string through the table we have already discussed. So once the base 64 conversion is done, we are taking first 7 characters out of it, and we are actually mapping that 7 characters from the long URL, which we'll discuss eventually going forward in our section in our discussion, right? So as I promised, I said that we'll discuss on why are we taking 7 characters, why not eight, why not six, why not four. So maybe I'll go forward and discuss about some back envelope calculation, so that you can also take a decision on should you take base 64, should you take base 62, should you take 6 character, 8 character, 4 characters. So based on these calculation, I think we can take that decision. So in base 64, we have 26 lower character, 26 upper character, 10 digits, and 10 additional characters like plus and forward. So if we take base 62, then 2 additional characters will be removed. I think based on these decisions, we can decide what base we want to take, and as well as if we take 6 characters, uh, I think in case one we can see total 68.7 billion unique URLs can be created. If we take 8 character, to 81.5 trillion unique URLs will be created, right? So the more character we take, the more uh, unique URLs can be created, right? The more base will take. When I say more base, I'm talking about 64 instead of 62, instead of 32. The more base we take, the more combination we can create, right? But it would cost us. The more base we take, the more characters we take, it would require some extra calculation and space. So based on that, we take that decision. Okay, let's discuss about if we send 1000 requests per second, then total 31.54 billion requests will be received per year. And if we take, uh, okay, 2.18 years, I think that is written for 6 character tiny URL. We can ignore it. So we can take a reference from the table at the bottom we have created. So let's talk about the 8 character tiny URL. The limit is to 81.5 trillion different combinations. So that will last for 892 years in case we are getting 1000 requests per second. If we take the case 2, then 10,000 requests per second. In that case, total 315.36 billion requests will receive per year. And again, if we take 8 character tiny URL, then it would still last for 892 500 years. So based on the load, based on the request per second we are receiving, I think we can decide whether we have to take 8 characters, 6 character, 4 character, or whatever it is. Okay, let's go back to our previous slide of TinyURL. So that's how we take 7 characters, and we create TinyURL and send it back to the user, right? So user uses that TinyURL and redirect it to the actual URL when user use this TinyURL, right? So let's go back to the construct of this service. These are short URL service where we discussed about key management service, which takes the long URL and created tiny URL. When I say created tiny URL, I'm talking about the 7 characters, right? So this key management service consisting of 3 services: Ashomatic, Base 64, and tiny key picker, and that's what the tiny URL service is, which is inside short URL service. If we take out the handle tiny URL out of the short URL service just to keep a core business logic inside one single module, and we also add a fast access cache to save the mapping of tiny URLs to fast access cache so that we do not make calls to persistent URLDB each time we get a call to get the long URL, so that that's how we can save a lot of cost and reduce IOPS on persistent URLDB. Going forward, what we'll do is we'll replace these component with actual Azure services, and we'll move ahead and create the high level architecture using this block diagram. When we will replace these components with the services of Azure, we'll also discuss the end-to-end flow and how these services will be interacting to each other. And once the flow and high-level architecture is completed, the discussion is completed, at last we'll discuss about how to implement the tinyurl service in Azure. So stay tuned. Going forward, we'll have a very interesting discussion on how to replace these services with actual, how to replace these block diagrams or component with actual Azure services, and then how these services will interact to each other, will complete the flow of tinyurl service, and then we'll finally implement this tiny URL service on Azure. So stay tuned and watch this video till end. Thank you so much. So let's start with replacing this component with the actual Azure services. So first, API management layer. The API management layer will be replaced with API management service of Azure, and this service is basically used to create RESTful endpoint. And all right. So the next service will be replaced by generate tiny URL and long URL retriever Azure function. So there would be one function. Do not get confused. I created two Azure functions. So there would you can see that there are two Azure functions visible here. Generate tiny URL and long URL retriever. Instead, there is a single Azure function created with two endpoints. First, put endpoint to create tiny URL. You make a request to you make a request with the long URL and you'll get the tiny URL back. So that is what generate tiny URL will do. And another get service will be long URL retriever. You make a call with the tiny URL, that is the 7 magical characters to long URL retriever, and you'll get back the long URL. So that's what this Azure function do with two calls, put call and get call. uh, I'll say key management service slash tiny URL service. So I have actually used tiny URL service as well at some of the places mistakenly. So please be mindful and my pardon for that. So do not get confused. Tiny URL service is nothing but the key management service. I have created Azure function with key management service, and I created all this video where at some of the places I use tiny URL service. So I forgot to replace this tiny URL service with key management service. Please be mindful for that. This key management service will be replaced by another Azure function. All the complex business logic would be performed by this key management service. So that's why we are using two Azure functions here. First, to perform all complex logic, like MD5 creation, base64, and picking up 7 characters from base64. That's what will be done through key management service Azure function, right? Now let's move on and replace the fast access cache with the Redis cache. Now I'll point out one thing, that in our practical we'll not be using Redis cache and API management, just to keep things short. Already video is very long, so that's why I'll not be using any kind of Redis cache and API management. That is optional. If you guys implement it, you can use API management and Redis cache as well. So in our practical example, we'll not be using Redis cache and API management. Let's move on and replace persistent URL DB with the actual database we'll be using, that is URL mapping database, a SQL Server database. So that's how we can replace this block diagram with the actual low level diagram, sorry, with the actual high level diagram. So that's how the HLD would look like when we replace the blocks with actual Azure services. So API management is a front-facing service which will expose the endpoints. Although in our practical example, not be using API management, will directly create Azure function with the endpoint. This API management can then access generate tiny URL and long URL retriever. Generate tiny URL is a put call or the endpoint with the put method. You make a request, you make a put call with the long URL in the request body to generate tiny URL and get a response back with the seven magical character. And long URL retriever, when you send those seven magical character to long URL retriever get call, you would receive the long URL, long mapped URL from that endpoint. These generate tiny URL and long URL retrieval will further make a call to key management service. It will perform all the complex logic, and that's why we will create a separate Azure function for that. Key management service, then maybe make a call to Redis cache. This we will not implement. It is optional. If you guys create your own tiny URL service, this is the idea. You can also use Redis cache to reduce the IOPS on the database where you would save your tiny URL and long URL mapping. Uh, Key management service will access URL mapping DB to save the tiny URL and long URL mapping as well as to retrieve that mapping. This is what the key management service will be using. All right, so this is our final HLD. Let's go back to our original discussion. So a user through tiny URL getting redirected to the actual large URL and accessing Azure portal, right? Let's look at how services are interacting to each other and how would the flow look like when we implement it. Let's shrink the URL a bit so that we can understand the flow and we see it clearly, right? So we are making a put call to API management, although we are not using API management, but in case you want to use API management, you can use API management in front of the Azure function. So we are making a put call, API management receiving that receiving that original URL and making a put call or connecting that API to generate tiny URL, which is one of the uh, So this is the final HLD, and let's go back to our original discussion. A user through TinyURL trying to access the original large URL, and when user access the tiny URL, it gets redirected to the large URL. Let's discuss about how a flow would look like in the HLD. Let's shrink the URL a bit so that we understand the flow clearly, right? Uh, a user is making put call to API management, although we are not using API management, but in case you want to use API management in front of your Azure functions, you can use it. So API management further sending that URL to generate tiny URL, a put call to generate tiny URL. It's a kind of mapping of API management to generate tiny URL, right? That URL is passed on to generate tiny URL, and then further tiny URL is passing on that URL to key management service. I think the animation is visible. Key management service is performing or you can say transforming that URL to MD5 and then base64 and then taking seven magical character or a kind of tiny URL and then saving that seven character mapping to the URL mapping TB. So these seven characters are mapped to the actual URL. That's what key management service would do. And then this tiny URL will be returned back to generate tiny URL as a response. Um, and then further generate tiny URL will send the response back to the API management. And then now the API management will return this tiny URL back to the user. And that's how the tiny URL would look like when the user would get the response back. So now let's look at the final and last section of this HLD discussion. Now, how would we retrieve the long URL from these 7 characters? So we'll make a get call to the API management endpoint, or this service anyways is optional service. So we can directly make a get call to long URL retriever as well in our demo, the live demonstration. This is what we'll see. So you can also ignore HTTPS forward slash tinyurl.com because that is not required. We'll only pass the 7 characters when we make a get call to receive the long URL. So when we make a get call, we pass on the 7 character, and in return and in response, we'll receive the mapped long URL to these 7 characters. So uh, first that request will land to API management. API management would map that get endpoint with long URL retriever endpoint. This is again a get endpoint in Azure function, and then long URL retriever would make a get call to key management service and will pass on the 7 character as a parameter, query parameter to key management service. All the complex logic is written inside key management service. That's why we are segregating key management service with the tinyurl and long URL retriever Azure function. Key management service will further make a query to URL mapping DB and will get the long URL back from the query which key management service would make to URL mapping DB, and the mapped long URL will be returned back to the key management service. We could see that in the animation as well. So key management service will send a response back to the long URL retriever, and in the response, it will send the long URL received by the URL mapping DB. The long URL retriever will then send that response back to key API management with that long URL, and then API management will send the mapped long URL as a response back to the user. So now this is what will be received to user in case they make a get call with the 7 characters, and will receive this long URL back. And anyways, we can access the Azure portal using that long URL. So eventually, if we see how would it look at the portal. When I say portal, I'm talking about the TinyURL service portal. You make a call to that TinyURL, and then at the backend, that's how things would be working, and you would be redirected to the actual mapped long URL to that TinyURL. So I think that's it from my side.